Okay, class, so we're going to take a look at the product rule. So if you notice, for some of our functions, we can easily distribute, but once in a while, we're going to have functions where distributing out our terms is going to take a little longer than we would like. So there is a shortcut for that, which is called the product rule. And you see it there on your worksheet, and it's this equation that has f primes and g of x's and g of primes and f of x's. But I'm going to teach you a phrase to kind of help you remember. And that phrase is, let me undo that, is the first term times the derivative of the second term, right here, plus the second term times the derivative of the first term. So what's going to happen is when you write these, like we know product means multiplication. So when you see terms being multiplied together, instead of distributing them, you can actually use the product rule as a shortcut. So let me give you an example of how this is done. And this is one of the ways that I like to solve these problems to kind of just give me an idea of where my functions are, where my terms are. What's my f of x, what's my g of x. So if I take a look at this equation right here, y equals 3x to the fourth power times sine of x. Although it looks like one term, I see two variables here. My first variable is this x to the fourth section. My second variable is this x within the sine function. So if you listen to how I say it, can't this be read 3x to the fourth times sine of x? Well, there's your product rule right there. So what I usually do is I underline my first term. So my first term in this case is 3x squared. And then I underline my second term with 2 lines. So why I'm going to split this equation actually into 2 parts. First part is 3x to the fourth. Second part is sine x. So I am going to copy this right here. Let's copy that. And I'm going to want to paste this just so we can follow the phrase. Right, so, come on. Let me see. Okay, so I'm going to paste this. I'm going to lower it real quickly right here. So, according to this, I'm going to take my first term, which is my first underlined term, and put that in parentheses. So 3x to the fourth, parentheses. Then it says take the derivative of the second term. Well, according to our previous lecture, the derivative of sine is cosine of x. So I'm going to write in cosine of x. The next piece tells me to use an addition sign. Then I will use the second term, which according to our problem is the sine of x. I'm going to put in the sine of x, and just to keep consistency, let's put parentheses around here. And I'm going to take the derivative of the first term. So I'm going to take the derivative of this, which is 4 times 3 is 12, times x to the third power, since 4 minus 1 is 3. And all I'll have to do now is simplify this. And to simplify this, I'm just going to get rid of my parentheses. So I get 3x to the fourth cosine of x plus, and I'm going to move this term to the front, 12x cubed sine of x. And this is equal to your derivative, dy dx. So this is a perfect example of why you have to use the product rule, because there's no way to multiply out this 3x to the fourth and sine x if you don't have an x term. So by using this rule, we can still find a derivative, which if I wanted to using the definition of the derivative, it's still possible, but a lengthier process. So let's try this again. And so now if I take a look at this problem, please let me know what rules I could use. Alright, so I can use the power rule because I have a power. I can also use the constant multiple rule because I have a number right here attached to a variable. Since I have this minus sign, that tells me I can use the difference rule. And I have a cosine function, which is a derivative that we also just learned. So what I'm going to do is break this apart into all its pieces that can be differentiated. So I'm going to take a look at this first piece. Well, can I take the derivative of 7x? This is what we did last class. H prime of x is equal to, like I said, I'll take the derivative of 7x, which in this case is just 7, right? And then I'm going to subtract right here. I'm going to subtract out by doing the derivative of the second term. Now the problem with the second term is I have an x here as well as an x here. Since I have two x's in this one term, what kind of rule do I have to use? Good. I have to use a product rule. So I'm going to separate this out into my two terms, and I get an x squared right here, and I have a cosine x right there. So I've separated this out into my two terms, right? There's my first right here, and this is my second. So if I follow the rule again, and let's just make sure to keep this negative x with that x squared. So if I continue solving this, I get the first term, which is minus x squared, times the derivative of the second term. The derivative of cosine from last lecture is negative sine of x, plus the second term, which is cosine of x, times, let me just scoot all of this over. Room. Right, let's scoot that over there. And so if I continue this, we did the second term times the derivative of the first. Well, what's the derivative of x squared? Correct? The derivative should be 2x. So once again, I'm going to rewrite this so I can simplify, and I'm going to get h prime of x is equal to 7 minus, and a minus right here, give me a plus x squared sine of x. And right here, I'm going to move my 2x. Oh, my apologies. You know what? I forgot my sign. This is a negative x squared, so this actually should have a negative right here. So that's going to give me a negative 2x cosine of x. And just for the sake of consistency, I'm always going to try and put my sine and cosine, all my trig functions, towards the end of the term. And by using the product rule, the power rule, the rules for cosine, and the constant multiple rule, I was able to find this derivative right here. So let's try another problem. But now let's try one that has three functions to it. So looking at your sheet of paper, I'm going to have a function f of x multiplied by a function g of x multiplied by a function h of x. So our pattern last time was, if I go back here, the first term times the second term, and then the second term times the second term times the first term. Well, since I have three, I'm going to expand it out a little bit and say the first derivative times g times x, and then I'm going to do the second function's derivative, g prime of x, times just f of x and h of x. And finally, I'm going to take the derivative of h of x and multiply it just by the regular f and g functions. So let's separate this following example into our three functions. So once I see those parentheses, that already gives me an idea that that's one term. Right? So this is 4x cubed plus 5 times cosine of x, so that's my second term, times sine of x. If you notice, every time I broke this apart, there was an x that separated them. So there's an x in this piece, there's an x in this piece, and there's an x in that piece. Okay. So let's follow our rules. The first rule says take the derivative of the first term. So the derivative of the first term here is dy dx is equal to 12x squared. The derivative of 5 is 0, okay? Then it says multiply by your second term and multiply by your third term. So I'm going to multiply this by cosine of x, sine of x. Okay. Then I need a plus sign right here, plus. Now I take the first function, which was, in this case, 4x cubed plus 5, multiply it by the derivative of g prime of x. Well, the derivative of cosine of x is negative sine of x, times my third term, which is just sine of x. Right? Then I do it again. Now I'm going to take the original f of x, which is 4x cubed plus 5. I'm going to take the original g of x, which is cosine of x, and I have to derive the last term, which is sine of x. And so what's the derivative of sine of x? Okay, it's cosine of x. So now all I need to do is to actually simplify this out. Let's use a different color. I'm going to get dy dx. This first term right here is already simplified. I get 12x squared cosine of x sine of x. Let's take a look at the signs for our second piece. This one's positive, negative, positive, which gives me a negative. I keep my 4x cubed plus 5. And what's sine times sine? That's going to give me sine squared of x. Then I continue on, and I get a positive, and all of these are positive right here, so I get plus parentheses 4x cubed plus 5 times, what's cosine times cosine? I get cosine squared of x. So by taking a look at this function, we can expand this out to products that have more than two terms. So in our previous examples, we've always had two terms right here. In this one, I have 1, 2, 3. If I were to do a derivative that has 4, I would use the same pattern, except I would add on another term right here, another term right here, another term right here, plus the 4 different functions of f of x, g of x, h of x, and let's call it j. Let's say it's j prime of x. I would have to multiply all that in these sections as well. Okay? But typically, we deal with terms that have two. We deal with problems that have 2 products or 3 products. So now, just like we've done for all our other practice problems, we've always tried to see, well, can I use this method in multiple ways? So according to this, it says find a derivative with and without using the product rule, and compare your answers to ensure that they are the same. So first, let's start with the product rule. This one's nicely set up since I already have parentheses to represent our multiplication. So 3x to the 4th minus 5 is my first term. X squared minus 4x plus 2 is my second term. So if I start taking the derivative, I get the first term, which is 3x to the 4th minus 5. Sorry, that's a 4 right there. Times the derivative of the second. The derivative of this is 2x minus 4 plus the second, which is x squared minus 4x plus 2 times the derivative of the first, which is 12x cubed. Right? So let's distribute all of this out, and you're going to get f prime of x is equal to, let's see this, it's equal to 6x to the 5th, right, minus 12x to the fourth, right here, minus 10x plus 20. And if I distribute this and keep them positive, I'm going to get plus 12x to the fifth minus 48x to the fourth, and let's see if I can squeeze it in here, plus 24x cubed, right? And so now what I'm going to do is I'm going to collect all my like terms so I can simplify this function. And if I take a look at this, I get f prime of x is equal to this 6x to the fifth can combine with 12x to the fifth to give me 18x to the fifth. I have an x to the fourth over here and an x to the fourth over here, and that's going to give me minus 60x to the fourth. And then let's just put our numbers in our exponents in order. So the next term after the x to the fourth would be this 24x cubed. And then if I continue this on, I'm going to get a minus 10x plus 20. So by using the product rule, I get this answer right here. So what I'm going to do is I'm going to copy this problem, but I'm going to do it on a new page. So I have f of x is equal to 3x to the fourth minus 5 times x squared minus 4x plus 2. So if I'm not allowed to use the product rule, that's the only thing I can do to this function right now. Well, as of right now, all I can do is rewrite it, right? So if I distribute these right here, oops, right there and right there, and we did this, oops, distribute, oops, hold on right there. Let me get my pen back. Let me distribute to the first term right here, the second term, and that term right there. So if I do my multiplication, I get 3x to the sixth minus 12x to the fifth plus 6x to the fourth minus 5x squared plus 20x minus 10, right? So I can combine a few of these. So if I rewrite this again, I get f of x is equal to 3x to the sixth. Oh no, actually I'm good with my function. So let me erase this real quickly. And let's actually take the derivative right away. So if I do this, I get 18x to the fifth minus 60x to the fourth plus 24x to the third minus 10x plus 20. So this is the answer that I get when I distribute first and then take the derivative. So if we were to compare our two answers, here you go, side by side, I get 18x to the fifth, 18x to the fifth, negative 60x to the fourth, negative 6x to the fourth, plus 24x cubed plus 24x cubed minus 10x minus 10x, 20 and 20. So this is proof that no matter which way you do this, you're still going to get the same answer. So depending on the problem, if you do like to distribute, you're more than welcome to do it this way. But you're also more than welcome to solve it with the product rule. And later on in a couple of lessons, you'll see when is it better to use the product rule and when is it better to use the distribution. So let me unsplit these screens. Alright, and if I move on, I believe we just have a few more problems to take a look at. And I think there's only two. Yes, there's only two more problems to take a look at. So here, I want to take a look at equations of tangent and normal lines of a function given the certain x values. So these directions are just like the directions from last class, except now I'm going to have to use a product rule. So, according to our prior knowledge, let's just write the information down. A tangent line is when I use y minus y1 equal to f prime of x times x minus x1. Right, so let's just kind of plug all these things in already. I already have my x, so I know I have an x minus pi in this function. Well, how do I find my y? 1. Well, I would plug this into f of x to see what our answer is. So if I plug that in, let's do it right here in the bottom, I get f of pi is equal to, alright, I get 3 pi squared minus pi times sine of pi. Well, if you take a look at, or if you just remember what the sine of pi is, the sine of pi is equal to 0. If this is equal to 0, then my whole function is equal to 0. So f of pi is equal to 0, which also means I'm going to get y minus 0 for this function. Now if you notice, the only thing missing is the slope right here, and to find the slope, what do I have to find? Good, I'm hoping you said it, but you do need to find your f prime of x. So let me shrink this down right here. Let's just shrink this down right here so that way it's not in our way. Here. I'm going to make it just a tad bit smaller so we have more room. Look. There's my button. I'm going to make this a little bit smaller so we have more room for this. And if we then solve this by using our, by using a product rule, I am going to find my two terms. Well, once again, this is nice because I have my first term in parentheses and my second term right next to it. So if I solve this derivative, I'm going to take the first term right here times the derivative of the second. Well, the derivative of the second is cosine of x plus the second term, which is sine of x, times the derivative of the first term. The derivative of that is 6x minus 1. Okay? Well, to get the answer that goes in here, I have to plug in my x. So to do this, I get f prime of pi, is equal to 3 pi squared minus pi cosine of pi plus sine of pi times 6 pi minus 1. Well, let's take a look at our trig functions again. And if I take a look at sine of pi, we actually just solved for that. Well, what's the sine of pi? Sine of pi is 0, just like what we found here. So this whole term is going to cancel out. So now we need to figure out, well, what's the sine of cosine of pi? So let me scroll down just a little bit for here. Well, if I take a look at cosine, the sine of cosine of pi is negative 1. So f prime of pi is equal to 3 pi squared minus pi times negative 1, or rewritten is pi minus 3 pi squared. Since I found f prime of pi, where can I plug this into? Good. This can be plugged into here, and if I were to simplify this, I would get y minus 0, which is y, is equal to this answer right here, pi minus 3 pi squared, close parentheses, times x minus pi. Good. So this is our tangent line. Okay. Well, if I read the directions, am I only looking for the tangent line? No, I also need the normal line. So just to refresh, the normal line is y minus y1 is equal to negative 1 over f prime of x, the negative reciprocal, the slope, times x minus x1. So all I'm going to do is I'm going to use the same exact information as my tangent line, but I need to take the negative reciprocal of this derivative. So if I do this again, I'm going to get y minus 0, which is y, equals negative 1 over, I'm just going to flip this down here and do pi minus 3 pi squared times x minus pi. And now you have the equation for the normal. So both of them use the point slope form. The only difference is, do I use f prime or do I use negative 1 over f prime? Alright, so let's take a look at our final problem for the day. And this problem is slightly different from everything else because I don't have actual functions that give me details. I just have general functions called f, g, and h. Well, since we know these rules, we can actually use all of our five, if you call it the trig rules, 6 rules now to solve these problems. So it says find h prime of x and h prime of 1 given the following. So what I'm going to do is, let's start off with this problem, the first one right here. Take a look at this problem right here. I'm going to take the derivative as if I already knew what these functions were. So if I take, I'm going to rewrite this just to be clear. 3f of x minus 4x squared g of x. So according to this, I need the derivative of h of x, which in this case is just h prime of x, equals, what rule can I use for this first term? I have 3 times f of x, which is actually the same as a constant multiple, because is there a variable attached to this 3? No, it's just a constant, a coefficient that we're going to use. So I can say this is 3f prime of x, because I know the derivative of f is f prime. Then I take a look at this function right here. Well, how come I can't do what we did to this function, to this term? Well, the problem is it's a multiplication term. I have a first term here, a second term here. So let's actually use our rules to solve this out. So I get the first term, which is minus 4x squared, times the derivative of the second. Well, I don't have a g of x per se, but I know the derivative of g of x is g prime of x. And I do plus the second term, which is g of x, times the derivative of the first term, which is negative 8x, parentheses. So now what I'm going to do is I'm actually going to follow this piece. I'm going to follow this piece of our problem, and I'm going to plug in a 1. So I get h prime of 1 is equal to 3 f prime of 1 minus 4 times 1 squared g prime of 1 plus g of 1 times negative 8 times 1. And if I make more room over here, well, actually, let's squeeze this in. I don't know if you can see that. But now I have all these pieces of information to plug in to here. So I'm going to get h prime of 1 is equal to 3 times f prime of 1 is equal to negative 3 minus 4, 1 squared is 1, g prime of 1 is equal to 4 right here, so times 4, plus g of 1 is equal to negative 1 times 8 times, negative 8 times 1 is negative 8. So now all I'm going to do is solve this and finish my algebra. H prime of 1 is equal to negative 9 minus 16 plus 8. And that's going to give me negative 25 plus 8, which is equal to negative 17. Good. So that's the end of this lecture. What I'd like you guys to do is to try and solve this problem here. So let me highlight it for you. I'd like you to try and solve this problem right here in the same method that we did for this last problem. And then I'll see you in class and we can continue this practice time period.